All right, viewers, we are getting into the heart of pre-calculus. We are going to start trig. We're going to first review what you learned back in geometry. So little trig to start, quick review of SOHCAHTOA, and then special right triangles you'll watch tonight for homework, and then we'll do the unit circle tomorrow that involves the special right triangles. Okay, so let's review. Sine, cosine, and tangent. You have learned these ratios before, and you've got to have them memorized. I don't know which way you prefer to memorize it. SOHCAHTOA. I just remember Oscar has a heap of apples. So Oscar has a heap of apples. That's just how my teacher taught me. So, but the sine ratio is the opposite side over the hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So take a look at this diagram here. We've got a right angle. The side that is opposite the right angle is the hypotenuse. And then the other two sides are going to change depending on which side you're referencing. So if you're referencing this angle here, this side would be opposite. However, in a different color, if you were referencing this angle, then this side would then be opposite. Okay, and then whatever the other one would be adjacent. So the reciprocal functions are, you know what a reciprocal is, right? When you take the numerator and the denominator and switch them. The reciprocal of sine is the cosecant, and that is just when you switch the numerator and the denominator. Same for secant, that is the reciprocal of the cosine. And the cotangent is the reciprocal of the tangent. Now, in examples like the next one, you're asked to evaluate the 6 trig ratios for the following right triangle. Okay, so you're given two sides, and before you can start, because you're going to need opposite, hypotenuse, and adjacent, you got to find the third side. In order to do that, we've got ourselves a right triangle, so we're going to use Pythagorean Theorem. Now, you don't have to write out all the steps to Pythagorean Theorem. You are in pre-calculus now, so if you can do this, in your head or with as least number of steps as possible, that is perfectly fine. Just, it needs to be right. So we get 20 is b squared, so b is root 20. Simplified, that is 4 times 5, so 4 comes out, and that becomes 2 square root of 5. So I'm going to just write that over here, 2 square root of 5. All right, now I'm going to fill that in for all my trig ratios. So this side is the hypotenuse, right? And now we are referencing angle A here. All right, so the sine, okay, so where are we at? This would be the opposite side over the hypotenuse. And then I'll simplify that in just a second. The adjacent side over the hypotenuse is cosine, and the tangent is the opposite side over the adjacent side. Now, those need to be simplified. So if 2 goes into 6 evenly 3 times, so that's root 5 over 3. 4, 6 can be reduced to 2/3, and 2 goes into 4 evenly. So I simplified that one. Now, the cosecant, I would just switch, I would just flip them. Let me move this over. All right, this is already simplified. So I would flip the 3 and the root 5. And now we can't leave the root in the denominator. We need to rationalize the denominator. So we multiply by root 5 over root 5. And we get 3 root 5 over 5. Done. The reciprocal of 2/3 is 3/2, and the reciprocal of root 5 over 2 is 2 over root 5. Multiply by root 5 over root 5, and we get 2 root 5 over 5. That can't be simplified either. So try the next one. Press pause, try it, and I'll give you the answers. So here we go. Take a look. First, you got to do Pythagorean Theorem to get the missing side. In this case, it's the hypotenuse, and you don't have to deal with any crazy numbers in this one. All right, so we're going to move on. An angle is made up of 2 rays that share a common vertex, right? Here's your vertex, vertex, vertex. One of the rays is called the initial side. Initial is where it starts, and then the other one is called the terminal side, where it ends. Angles, not spelled right, can be positive if the terminal side rotates counterclockwise, so the opposite direction of the clock, counterclockwise, positive angle. If it goes the other direction, which is clockwise, the direction of the clock, that's a negative. That'll be a negative angle, okay? So angles are said to be in standard position if the vertex is at the origin, so in both of these are examples of standard position, and the initial side is on the positive x-axis, so the initial side has to be over here. Okay, so both of those are examples of angles in standard position. So let's see if we can't draw these 3 examples here in standard position. So 240 degrees, that's above 180, right? So I'm going to be going around, and this is a positive 240, right? So I'm going to be going this direction, 180 degrees plus an additional 60. So it's about right there. So there we go. 240 degrees. Okay, and I should draw my initial side. In fact, let me do this in a different color. Here's my initial side, and here's my terminal side. So there you go, there's your angle. 500 degrees goes around once, and then 360 plus an additional 140, which goes 90, somewhere over here, right? There we go. So the initial side would be here. The end would be right here. Now a negative angle is going to go the other direction, right? 50 degrees. So it's going to go something like that. Now these are just, that doesn't look exactly like 50 degrees to me, but it is what it is. All right, moving on to what a reference angle is. A reference angle is the acute angle between the terminal side of an angle and the x-axis. The trig ratios of an angle and its reference angle are the same value. They may be a different sign. We'll get into that in just a little bit. I think you'll understand this better once we do these examples. So 30 degrees. 30 degrees goes like that. Right. So the reference angle, basically how far away is that terminal side from the x-axis? Here, it's the same as the angle, 30 degrees. But sometimes we'll have an angle like 135 degrees, which is 90 plus 45. So here's your initial side, and then that's about 90 plus 45. Okay, but now how far away is the terminal side from the x-axis? Well, the closest way to get to the x-axis is this direction. So how far is that? Well, if the initial angle is 90 plus 45, then that distance, the reference angle, you can just do 180 minus 135. But I usually just think, well, there's 45 left. So however your brain figures out that it's 45 degrees is perfectly fine. And then the last one, 330 degrees. Well, the whole thing, all the way around one time is 360 degrees. So 330 is right about there, right? And that's 30 degrees away from the x-axis. So this reference angle right here is 30 degrees. Okay, so that's what a reference angle is. All right, we're getting into another way to measure angles. Another unit is, besides degrees, is radians, and there are other ones that will be later and that you will learn about. So another way to measure angles is radians, right? So to define a radian, it's consider a circle with the radius r centered at the origin. So 1 radian is the measure of the angle in standard position whose terminal side sweeps out an arc of length r. Okay, and when we're dealing with the unit circle, our radius is always going to be 1. So because the circumference of the circle is 2 pi r, then there are 2 pi radians in a full circle with a radius of 1. So the degree measures and the radian measures are therefore, they're related, because you can say 2 pi equals all the way around 360 degrees. So pi equals 180 degrees. So we can use that to convert between degrees and radians. And this is really, if you've done unit conversions in chemistry, this is a really, really basic way to do this. The only thing is that I won't give anything super complicated. These examples that you're about to do are a little bit more complicated. You're not going to have a calculator to do this. So if you're working in degrees in the numerator and you need to convert, right? So that means your answer should be in radians. When we multiply, we're going to need to multiply by something equal to 1. I'm going to multiply by pi over 180 because that is what I call, in geometry, if you have me for geometry, special 1, because pi is the same as 180, and that's that whole thing. We're not going to change the value of that expression or that degree. So that's just equal to 1. So I'm going to multiply 125 degrees by 1. Now, pi over 180, the degree in the numerator, which is the unit, and the degree in the denominator, which is the unit, those units are going to cancel. And the units left, when you simplify, you get 125 pi over 180, and that's in radians. And then you would simplify as best you can. You'd get 25 pi over 36. Okay, now, next one. This one, B, is in radians. We need to convert that to degrees. So we're going to put, in our special 1, we're going to put our degrees in our numerator, and then our pi in the denominator. Now, what happens when we multiply straight across? Before you even multiply, simplify. Those pi's are going to cancel. So I've got negative 180 over 12. When I simplify, I get negative 15 degrees. See if you can try the rest, and I'll show you the answers. All right, so here we go. Take a look, pause it, look at your answers, see if you have any questions. We can talk about them in class. All right, last thing we need to do here. We're going to count all the way around this circle here first. So if I go all the way around the circle and it's all the way around is 2 pi, right? That means halfway around is pi. And that means 90 degrees would be then equal to pi over 2. And then 270 would be equal to, that's a pi by the way, 3 pi over 2. Now sometimes we have to count not in with a 2 as our denominator in halves. Sometimes we need to count in fourths or sixths because I need to sketch this angle, 3 pi over 4, without converting. So I'm going to go ahead and try that. Well, we know that halfway around the circle is pi. Well, I'm counting in fourths, so that's equal to 4 pi over 4. Well, that means 90 degrees is 2 pi over 4, because that's the same as pi over 2. Well, where is 3 pi over 4? 1 pi over 4, 2 pi over 4, 3 pi over 4, right there. So I'm just going to write, oh, you know what? I'll do that again. Three pi over 4. And then how far away is that terminal side from the x-axis? That's the shortest distance. That is, in this, we're working in radians, so that reference angle is going to be 4 pi, well, let me just write it, 4 pi over 4 minus 3 pi over 4, and then pi over 4. You don't have to go through all that, but that's how you get it, okay? Now we're counting in sixths, so pi is equal to 6 pi over 6. Well, that's, if I'm sketching 7 pi over 6, we're going past that, right? And one more sixth. 7 pi over 6. This is 6 pi over 6. There you have 7 pi over 6. So the reference angle, how far is it away from the x-axis, is 7 pi over 6 minus 6 pi over 6. So you get pi over 6. You might have to watch this more than once. Some people have trouble with reference angles. It will not be difficult for you at the end of the year, but it's still totally new. Okay, so now we're counting in thirds. So I know that from 0 to 6 pi over 3, right? That's equal to 2 pi. Halfway around is pi, 3 pi over 3. Well, I'm sketching 5 pi over 3, so that's going to be right here. So that's 3 pi over 3, and then I got 4 pi over 3, right? And then I've got 5 pi over 3 for a total of 6 pi. I'm taking that whole circle and I'm cutting it into 6 pieces. So, okay, where am I at? Okay, so what's the reference angle? The reference angle is 6 pi over 3 minus 5 pi over 3. So that's just pi over 3. And the last one, again, we're counting in fourths, 4 pi over 4. That makes 5 pi over 4 here, past 4 pi over 4. So the reference angle will be 5 pi over 4 minus 4 pi over 4, which is equal to just pi over 4. Okay, make sure you watch the right triangle review video before the unit circle video that's next. You don't have to do that tonight, but for next class.